Let's see part 7 of ionic equilibrium. Ionic equilibrium. Right. So let's see hydrolysis of salt. Question will be based on hydrolysis of salt, buffer solution, Henderson equation, solubility, and common ion effect. So let's see the first question. pKa. So pK equilibrium constant of acid of dimethylamine, that is dimethylamine, and pKa of acetic acid CH3COH, right, are given. So pKa for this, for dimethyl amine is given, that is 3.27, and for the acetic acid it is 4.77 at temperature T Kelvin. So correct option for the pH of dimethyl ammonium acetate. So it is talking about the pH of dimethyl ammonium acetate solution, right? It is asked in 2021, right? So let's see the explanation for dimethyl ammonium acetate. So formula for that one will be di means 2, right? And methyl means CH3. So it is NHCO3. So this is your dimethyl ammonium acetate. So it is a salt of weak acid. Salt of weak acid. Right? And weak base. And weak base. So we know the pH for that one. So pH formula is 1/2 pKw plus pKa minus pKb. So this is the formula for this solution, right? So after putting the value, pKw we know that is 14. So it is the equilibrium constant of water. So pH of water we know after addition of concentration of H plus and OH minus is 14. So put the value, that will be the 14. pK value no, that is 3.27 now. And pKv value also known. pK value is 4.77. So it is, this is your pK value for weak acid. So this is your weak acid. So it is 4.77 minus pKv. This is acting as a base. So this will be the pKv. So put here minus 3.27. Now calculate this one. Then you will get 7.75. So it is little bit basic in nature. So this is the calculation of pH of dimethyl ammonium acetate. Now look at the question number 2. HCl was passed through a solution of. So we are passing HCl through the solution like calcium chloride and magnesium chloride and sodium chloride. So these are the 3 types of solution through which acid is passed. So which one will form the crystalline, right? So it is asked in 2020. So see, since calcium chloride and magnesium chlorides are more soluble than NaCl, right? This comes in the group 2, right? It starts from beryllium, magnesium, calcium, strontium, barium, radium, right? So this comes under the group 2. So group 2 is more soluble, right? Here group 2 is more soluble salt than NaCl. On passing HCl through the solution containing calcium chloride, magnesium chloride, and NaCl, then NaCl crystalline out. So more crystalline formed with this NaCl, right, after passing the HCl. So when HCl is passed through these all the three salt, then crystalline will be formed of through. So you can write conclusion at, so group 1 will form crystalline solid. So in group 1, general formula is NS1. So it will be hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. So this comes under the group 1. Now see the question number 3. Solubility product for the salt of the type AB. So AB is nothing but is your salt, and its solubility product KSP is given, that is 4 into 10 raised to minus 8. So what is the molarity standard solution? So it is talking about the molarity, you have to find it, right? So let's see, it is asked in 2020. So as we know, for this one, when AB dissociate, it forms A plus plus B minus. So this is S, this is S. So solubility product is nothing but concentration of A into concentration of B minus. So it will be S into S. That is the solubility product. So it is equal to S square, KSP. Right. So next see. Now we know solubility product, we have to find the S. That will be the concentration. So S is nothing but it is the square root of solubility product. So we know the value of KSP, that is 4 into 10 raised to minus 8. Now take the square root. So square root of 4 is 2 and 10 raised to minus 8 is 10 raised to minus 2. So it is S. So S is nothing but is your solubility. Solubility is also called as concentration. So it is also represented in the form of concentration. So this value we have got, right? So molarity will be how much? It is 2 into 10 raised to minus 2. So this will be the answer, right? Now see the question number 4. Which among the following salt solution is basic in nature? So it is talking about salt solution which is basic in nature. Basic in nature. Right. So let's see. Now see the first. Sodium acetate is salt of strong. So there is a compound name, that is sodium acetate. So general formula is CH3CONA. So this is your sodium acetate. So it is a combination of a strong base, right? Because NaOH is coming, Na is coming from NaOH, so it is a strong base, and acetate ion is coming from weak acid. So this is your weak acid, right? So the nature of the solution will be basic, right? Because this is the strongest part, so its dominance will be more. So this solution, sodium acetate, is basic in nature due to a strong base. All the other given salts are of strong acid and weak base. So they all form the acidic solution, right? Other options are coming from strong acid and weak base. So it will be forming the acidic solution, right? So you can write this part also, like CH3CONA. When react with water, it again form the acetic acid. So suppose this is your Na plus cation and this part is minus acetate ion, and this will be the H plus, this will be the OH minus. So acetate ion will attract the H plus and this Na plus will be attracted towards NaOH. So it will be CH3COH plus NaOH. So this is a strong base, this is your weak acid. So write this answer.